Good morning students. Today we study about structure of atom and third chapter atom and molecule chapter we discuss about Dalton's atomic theory. According to Dalton's, atom is indivisible, means atom is not divisible, not cut. A British scientist John Dalton gave atom is not divisible, or we can say indivisible, not cut. But students, many scientists discover the atom have charged particle. The scientist Sir J. Thompson find atom have a particle that is negatively charged, and that particle name is electron. It represents like small e and negative charge. And another scientist E. Goldstein identify another particle by canal ray. Canal ray means those rays made by positively charged. That particle name is proton, and that represent like small p plus positively charged. After that, earlier only these two particles discovered in atom, electron and proton. Later on, in 1932 discovered another particle, that is neutron. And who discovered this neutron? James Chadwick, a scientist, discovered a neutral particle, and that name is neutron. It represented by small and no charge. But J. Thomson and E. Goldstein earlier discussed. J. Thomson in 1898 and E. Goldstein approximate 1886. This given identify the two particles, positive and negative. So scientists assume how they are distributed in the atom. So first the scientist gave a model of atom that known as Thomson's model. Thomson's atomic model. According to Thompson, what name of that model? That is plum pudding, Christmas pudding. Thomson's belong to Britain, and pudding as a sweet, like spherical shape. And in this sweet similar to our laddu, or we can say watermelon. Reddish part in watermelon like edible part, and the black color seeds are embedded in that reddish part. In similar way, Thomson gave this pudding, this positively part equally distributed in the atom, and negative part embedded in this. And positive and negative, overall atom is neutral, because that only two particles discovered. One is negative particle, that is electron. Other remaining part is positive particle, that one protons. This one negative. And both charge is equal, magnitude is equal, and its charge assume -1, electron charge -1, proton +1. Although actual charge is different, we will study in 11th class that what is actual charge. This charge is 1.6022 into 10 to the power -19 Coulomb. This one is actual charge, we will study in 11th class, but this electron, this charge we assume 1 means -1, and proton also similar charge, that known as +1. Overall atom is neutral. स्टूडेंट्स, हम इसको ऐसे समझ सकते हैं डेली लाइफ में, जैसे हमारा लड्डू होता है, बेसन का लड्डू, जो येलोइश पार्ट होता है वो पॉजिटिव पार्ट, और जो उसमें काली मिर्च और ग्रीन और लाल रंग की जो बूंदी है वो नेगेटिव पार्ट। पॉजिटिव और नेगेटिव दोनों पार्ट का जो चार्ज है वो इक्वल होता है। ओवरऑल एटम इज न्यूट्रल। फर्स्ट मॉडल गिवन बाय थॉमसन इन 1898. 1898. So atom is like this. After that, another scientist, Ernest Rutherford, go in detail about the structure of atom. And before understanding the Rutherford model of atom, we should know about what is radioactivity, what is radiations. So now we explain radioactivity first. Now students, a scientist, Henry Becquerel, explained a phenomena that known as radioactivity. What is radioactivity? Now we will explain scientist Henry Becquerel. This scientist explained a radioactive substance like radium, thorium, uranium and other substance, those release radiation continuously. That substance we placed in a lead chamber. Lead as a metal. This one is a lead chamber. So this one is a radioactive substance, and so radiations are released out in this way. The radiation is released. What type radiation is? These radiation alpha, beta, gamma, delta. But students, we want to specify this radiation. What happen if we placed a magnetic field? If we place this side a magnetic field, suppose this magnetic field is positive plate. We know this one is positive plate. Other side we take another plate. This plate is negatively charged plate. Negative charged plates we already know. So what happens when we place these two plates? Then some particles move towards this side plate. Some attract towards this side. Some attract towards positive side plates, and some are released without reflection. So identify to do this. Those substances move towards negative plate, it means they are made by positively charged. So they are positively charged, and this one is negatively charged. Those substances attract towards negative plates, they are positively charged, and those substances attract towards positive plate, they are made by negative charge. Why? We know opposite charge to attract each other, and those substances, no deflection, no deviation, do not move any sides, they are neutral. So what are the name of these substances? These radiations. So those radiation move towards negative plate, they are known as alpha radiation. Friends, this one is symbol alpha radiation. So how can we represent alpha? Alpha is a helium nucleus. Helium symbol as He. We will study after later on. Helium as E, and its atomic number 2, mass number 4. It like represents. Friends, we will discuss about this. And helium, it is a helium nucleus. So we remove 2 electrons. So alpha represent like this 2 plus. He, 2 atomic number, 4 mass number and 2 positive. Alpha is a helium nucleus. It is positively charged. When those substances move towards positive plate, they are negatively charged, that known as beta particles. Beta. Its name is beta particles. And they are high energetic electron. Beta is high energetic electron. Its mass is 0 and its charge is -1. So beta represent like this, 0, -1, because it is high energetic electron. And those are neutral, they are known as gamma. It's represent like this, like R, known as gamma radiation. So students, what are the speed of this? Space alpha particle is one step. So comparison, then alpha is lowest speed, then beta 100 times speed and gamma 1000 times speed. Means penetrating power, it's move to other sides. हम इसको सिंपल भाषा में ऐसे समझ सकते हैं कि एक बच्चा अगर एक कदम चलता है, अल्फा एक स्टूडेंट है, गामा एक अदर स्टूडेंट एंड बीटा इज अदर स्टूडेंट. तीनों बच्चे एक साथ चल रहे हैं. अगर अल्फा एक कदम चलता है, बीटा 100 कदम चलेगा और गामा 1000 कदम चलेगा. मीन्स गामा हैव हाई पेनिट्रेटिंग पावर, गामा इज न्यूट्रल, alpha is positive particle, it is a helium nucleus. Why positive? Because it attracts towards negative plate and beta attract towards positive, so opposite charge to each other. So this phenomena known as radioactivity, and some substance release continuous, thus phenomena known as radioactivity. So this experiment conducted during Thomson's atomic model. So after that, English scientist, British scientist Ernest Rutherford took alpha particle. So now we will explain alpha scattering experiment of Rutherford. Now students, we explain Rutherford alpha scattering experiment. Ernest Rutherford, a British scientist, took a gold foil. Why select gold foil? Because gold, we know students, very less reactive and we can expand very thin foil. So he took a very thin gold foil and want to bombardment of alpha particle. We know alpha, what is alpha? Alpha is a positively charged particle. Alpha is helium nucleus and it's very heavy particle and very high speed. So we want to explain Thomson's model validity, because according to Thomson, positive part equal distribute and electrons embedded in this. So he want to prove the Thomson model atom is correct or not. So he took a radioactive substance that is a source of alpha particle, like any radium, thorium or any matter in this container, and after that he placed a lead plate. Lead is a very heavy metal, it's protect other side the radiation. So these radiation apply on a gold foil. This one is a very thin gold foil. So what happened? He placed a photographic plate to observe the experiment. This photographic plate, a layer placed over this, like on our TV screen, and in a film hall, that screen known as photographic plate, and that chemical known as zinc sulfide layer. Students, what is characteristics of zinc sulfide? When this radiation move, so this gets a sparkle. So when the bombardment, then what happen? Many particles strikes this, and almost all particle pass. Some move like this, other move like this. So like he observe In this way, easily can find out where the particles are strikes due to their photographic plate. When you observe bombardment of alpha particle, हम इसको ऐसा समझ सकते हैं कि जैसे मान लो हमारे आगे हम मैदान में दौड़ रहे हैं, आगे पत्थर पड़े हुए मैदान में, तो हम पत्थरों के ऊपर से दौड़ना है, तो क्या होगा, हम पत्थरों से टकरा के साइड से निकलेंगे या पत्थर को तोड़ के आगे जाएंगे, ऐसा ही होगा। तो अल्फा पार्टिकल ने क्या किया, अल्फा पार्टिकल मूव विदाउट डिफ्लेक्शन, नो डेविएशन, विदाउट मूवमेंट, डायरेक्ट हिट एंड पास थ्रू दिस लाइन. So he astonished when alpha particle, Rutherford ने ऐसा कहा, when you fire a 15-inch artillery shell, it's a tissue paper and again attack on you. मीन्स जैसे ही आप 15 इंच एक आर्टिलरी शेल से फायर करते हैं, वो एक पतले से टिश्यू पेपर से टकरा के वापस आपको ही चोट कर बैठता है. स्टूडेंट्स, आप जानते हैं जैसे हमारी बोफोर्स तोप है, बोफोर्स तोप से कितना बड़ा गोला निकलता है, वो एक जो हम टिश्यू पेपर होता है खाना खाने के बाद जिससे हम हाथ साफ करते हैं, उससे टकरा के वापस हमारे पे ही चोट कर बैठा. ऐसा उसने कहा. रदरफोर्ड बहुत ही आश्चर्यचकित हुआ. रदरफोर्ड वेरी एस्टोनिश्ड बिकॉज एटॉमिक स्ट्रक्चर इज नॉट करेक्ट अकॉर्डिंग टू Thomson model. Why? Because almost all alpha particle pass through straight line without deflection, no deviation. But one or two particles slightly bounce back. So if we draw the Rutherford actual model like this, our atom, and when he bombardment, then what happen? Almost all particles pass through straight line like this. They move like this one, in this way, and when they come near to this nucleus, then slightly deflection with some angle like this. One or two particle when direct hit, then it bounce back. So out of 12,000 one particle bounce back 180 degree, and some particle slightly deflection, 90%, more than 90% alpha particle, no deviation, no deflection, direct pass away. It means Thomson model is not correct. Why? Thomson model is like this. In this, positive part equal distribute and negative part embedded in this, like this. What happened? Because positive and this alpha particle both are equal charge, so there should be deflection, slightly deflection. हम इसको ऐसे समझें, अगर मैदान में हम दौड़ लगा रहे हैं, आगे पत्थर रखे हुए हैं, तो पत्थरों से हम टकराएंगे, तो हम अपना थोड़ा रास्ता बदलेंगे. So alpha particle also should slightly deflection, but it very astonished. So Thomson model could not explain alpha scattering experiment thoroughly. Almost so Rutherford explained an atom की structure. In that atomic structure, a nuclear model means atom have a different structure, not like this. Atom almost 90% is hollow space, and a center have very dense part that known as nuclear. So Rutherford explained nuclear model of atom. Now we draw the structure of Rutherford model. Now students, to explain Rutherford alpha scattering experiment, we can conduct an activity in open field. Students, if we can explain like this, एक ऐसा बच्चा है, ग्राउंड में एक दीवार है और दीवार में उसको पत्थर मारने के लिए बोला जाता है, तो वो बच्चा आंख बंद करके भी अगर पत्थर मारता है तो उसको आवाज़ सुनाई देगी कि जैसे इस तरह से आवाज़ आएगी, क्योंकि जितने पत्थर वो मारेगा वैसी आवाज़ आएगी। वो एक स्कैटरिंग, अल्फा स्कैटरिंग एक्सपेरिमेंट की तरह से है, क्योंकि बच्चे के सामने दीवार है। अगर वही ब्लाइंड बच्चा है और उसको आगे बारबेड फेंसिंग वायर, कांटेदार तारों पे पत्थर मारने के लिए बोला जाता है, तो क्या होगा? बच्चा अंधा है, उसको दिखाई नहीं दे रहा है, तो जैसे पत्थर फेंकेगा बहुत सारे पत्थर ऐसे पास हो जाएंगे, पता नहीं चलेगा, क्योंकि बारबेड फेंसिंग वायर में होल है, उन होल से वो पार हो जाएंगे। तो अल्फा स्कैटरिंग एक्सपेरिमेंट इसी तरह का रहा कि जैसे उन्होंने एक्सपेरिमेंट किया, बहुत सारे अल्फा पार्टिकल्स सीधे ही पास हो गए, कुछ पार्टिकल थोड़े से टकरा के स्लाइटली बाउंस हो गए। आउट ऑफ 20 और 12,000 1 और 2 पार्टिकल बाउंस बैक। इससे क्या हुआ? एटम में जो पॉजिटिव पार्ट है वो एक जगह नहीं हुआ। सो रदरफोर्ड concludes nuclear model of atom. In this Rutherford center have like this atom, and this one is a very dense part, and electrons are revolved around in this atom. Students, this one is dense part, this known as nucleus, and in this nucleus positive protons remaining, because that time only discover proton and electron, and electrons are revolved around this nucleus like solar system model. Students, in solar system what happen? Center have sun and planets are revolved around this fixed path like Mercury, Venus, Earth, Mars, in this way. So, and there is a force of attraction between sun and planets. In similar way, there is attraction between electrons and nucleus. So that force known as Coulombic force of attraction, and this force is directly proportional to charge on proton and electrons, and inversely proportional to their distance square. We already studied in physics these terms that known as Coulombic force of attraction. When we remove the sign of proportionality, then we get F is equal to K constant Q1 Q2 divided by R square. That known as Coulombic force of attraction. More the charge, more the force. More the distance, less the force. In similar way, there is a force of attraction between sun and planets. So that force known as gravitational force. It is directly proportional to mass of the planet m1, m2, and inversely proportional to distance square. So when we remove symbol this sign of proportionality, F is equal to capital G m1 m2 divided by R square. So in this way, Rutherford model of atom similar to solar system of model. Solar system or it's known as nuclear model of atom, because he identifies center of very dense part that known as nucleus. It is measured by positive charge. When the particle come to near the nucleus, then there is repulsion. Why repulsion? Due to same charge, because alpha particle have positive charge, so positive repulsion, so it's deflection. But when it move towards like this, then no deflection, no deviation, so almost atom is vacant hollow space. 90% atom is vacant hollow space, and there is force of attraction similar to gravitational force. Now students, he assume the size of atom. If the atomic radius, we calculate atomic radius is 10 to the power minus 10 meter. Radius of the atom is 10 to the power minus 10 meter. But what is the size of nucleus? nucleus size is 1 lakh times smaller than atomic radius. So nucleus radius is 10 to the power minus 15 meter. What is this radius? This nucleus radius, and atom radius is 10 to the power minus 10 meter. Students, this one is larger than this. 1 lakh times this smaller and atom is larger. If you imagine, nucleus is a like cricket ball, similar to cricket ball. Then what is the radius of atom? Radius of atom is 5 kilometer. If you imagine nucleus size is like cricket ball, then what happen? Atomic radius is 5 kilometer. You can imagine, if nucleus size is domestic fly, then atomic radius or whole atom size is like a football ground. So first scientist discovered the nucleus, and he got a Nobel Prize in chemistry 1908. Rutherford got Nobel Prize in chemistry in 1908 to study of this atomic structure, center, nucleus, students. But this model also some drawbacks, some limitation. He could not explain all the parameters of the atoms. So now we explain drawbacks or limitation of Rutherford model of atom, nuclear model of atom. Now students, we explain drawback or limitation of Rutherford nuclear model of atom. Rutherford nuclear model of atom is like this: center a very dense part that known as nucleus, and electrons are revolved around in this orbits like this. Students, if a electron remaining on this orbit, then what happen? Because it is a charged object, and when any charged object when revolve around this, then what happen? Change in direction. Due to change in direction, it acceleration, and due to acceleration, energy release as radiation. So when energy release in radiation, so its path is shrunk. It come nearer to nucleus, and ultimately when it come near, very near, then the proton are positively charged, electron negative, so it collapse in this nucleus. It means this type not happen. So what are the reason? So Rutherford could not explain stability of atom. Why? But center have sun and planets are revolved around in this solar system model. They are stable for a long time, like this one, Mercury, Venus, Earth, because they are not charged object, but electron is a charged object. A scientist, Maxwell Boltzmann, according to this scientist, if a charged object rotate or revolve around in this, so it acceleration, so change in direction, energy release as radiation. So what happen? Which type radiation? That radiation alpha, beta, gamma, delta like. So it path is shrunk, it come nearer to nucleus, and ultimately collapse in nucleus. And this happen within 10 to the power minus 8 seconds. So very small time, only within a fraction of second. Students, हम इसको एक डेली लाइफ से ऐसे समझ सकते हैं कि मान लो हमें ग्राउंड का चक्कर लगाना है, 400 मीटर ट्रैक का हम दौड़ लगा रहे हैं, तो स्टूडेंट्स आप फुल स्पीड में 400 मीटर ट्रैक के कितने राउंड लगा सकते हैं। जैसे हम दौड़ लगाएंगे सांस उफनेगा हमारा, और अल्टीमेटली फुल स्पीड से हम चक्कर लगाएंगे, 1 चक्कर 2 चक्कर 3 चक्कर, अल्टीमेटली उसके बाद हम दौड़ नहीं पाएंगे और हम बैठ जाएंगे और गिर जाएंगे। ऐसा ही इलेक्ट्रॉन के साथ हुआ। When electron move around in this nucleus, it come nearer to nucleus, ultimately it collapse. But this is not happen in planets because they are not charged, so they are rotate or revolute in a fixed path, so their energy is not released. But a charged object like this, so Rutherford could not explain stability of atom. This one is first limitation. In detail you will study in 11th class. Another drawbacks, another limitation, he could not find how many electron rotate or revolute. Means this is dense part and electrons are revolute. Means how many electron, he could not identify how many electron rotate and revolute. Another third limitation, he could not find out what is the energy of that electron. When electron remaining on this first orbit or second and third, which one is more energy or less energy? So he could not explain energy of that electron also. Fourth limitation or fourth drawback, what is the fourth drawback? He could not explain hydrogen spectrum. What is spectrum? When white light is split up into 7 colors. So students, in detail limitation and drawbacks you will study in 11th class. In 9th class you can understand Rutherford could not explain stability of atom. Why? Because a charged object rotate and revolute due to rotation, direction change in direction, energy release as radiation. Why energy release? Due to acceleration change. So its path is shrunk, come nearer to nucleus, and within 10 to the power minus 8 second it collapse in nucleus. This is not happen. If this is happen, then everything is collapse, but atom is stable, matter is stable, matter is made by atom. So Rutherford could not explain, although he successfully explained center have nucleus and dense part and all other things. So tomorrow students we will discuss a new model, that is Bohr's atomic model. If you have any problem then write in comment box, we will explain in next class. And like and subscribe, share the needy student. Thank you, have a nice day.